Okay, let's continue our subject as HPR equipment is. And right now we have to determine the baseline, and we have to find out what is that, and then we have to establish different main types of hydroacoustic equipment. So generally we have three main types of hydroacoustic positional reference system, and here are the names: long baseline, short baseline, and ultra short baseline. And before we continue, I would like to give the definition of the baseline. Baseline is the shortest distance between two HPR antennas or two HPR beacons at the sea bottom, depending on the HPR configuration type. And from this definition we have next conclusion. Some HPR systems require many antennas, and some HPR systems require many beacons at the sea bottom. And due to that fact, we have different names for each separate type of HPR equipment. And before we continue, please let's establish the length of the baseline for different type of HPR equipment. For ultra-short system, the baseline is always less than 10 centimeters between involved elements. For short baseline equipment, the distance between elements of the system varies from 10 till 50 meters. For long baseline equipment, we have the longest distance between elements. And here we have next borders from 100 till 6,000 meters and plus. It means maximum till 10 meters. 10,000 meters. And very often the students ask me the question about band frequency for HPR equipment. Also, I have the answer for that question, and my answer, as usual, based on some operational industry guidance, as IMCA M200 is. So band frequency used by HPR equipment. Low frequency varies from 8 till 15 kilohertz, and typical resolution is about 0.5 meter. Low frequency may be presented with the frequencies from 8 till 12 kilohertz and with a resolution about 0.05 meter. Medium frequency presented from 18 till 36 kilohertz and gives us a resolution about 0.25 meter. Medium frequency plays from 18 till 36 kilohertz and gives us a typical resolution about 0.03 meter. High frequency varies from 30 till 64 kilohertz and gives us the resolution as 0.05 meter. Extended high frequency varies from 50 till 110 kilohertz with a typical resolution about 0.03 meter. So at the moment is enough to cover the main typical baseline length and resolution parameters. Now in focus is long baseline, guys. The main idea of the long baseline system is that array of beacons is placed at the zip bottom as a baselines. So in that system we will have one transducer or one antenna and set of beacons at the sea bottom. And here are the main properties. 3 or more transponders located at known positions on the seabed and are interrogated by a transducer fitted to the surface vessel, towed body or autonomous object. If at least 3 ranges are measured from a mobile hydrophone to transponders at fixed coordinated seabed location, then hydrophone position coordinates can be computed. And the distances, of course, are received during calculation, which appears when we know the speed of sound in water and time moment. Long baseline acoustic systems provide accurate fixing over a relatively small area, and the accuracy for that system varies from 1% of the operational depth. This system normally in use for long-term projects and not popular for some temporary job. And guys, please remember the next key statements which are needed when you are going to pass assessment and to pass any interview. In long baseline arrangement, system measures the range to transponders that are known point at the seafloor. System measures only ranges, not angles. This is very important to understand. And then what we have, 3 ranges from known points give the position. With 4 transponders, the system can recognize drifting transponder. So the method of position determination is very common with the navigation method of fixing the position of the vessel when 3 distances are available to known stationary objects. So now let's talk about short baseline system. In short baseline system, a distance between 2 separately mounted hydrophones or transducers mounted on board of the vessel is creating the baseline for calculations. In short baseline systems, the baseline refers to the amount of transducers for such systems, which are usually deployed through dedicated tubes in the hull and are generally separated by between 10 and 50 meters, dependent on the form of the vessel on which they are fitted, and they create the rectangle on board of the vessel. This type of system requires a ping responder or transponder to operate the system. So, the conclusion from this statement is that the only one beacon needed at the sea bottom when you use short baseline system for determination of the vessel's relative position. Accuracy of this system is less than long baseline and normally varies over depth as a 5%. And let's say honestly, this type of arrangement is old school technique and not very popular nowadays. In a short baseline system, the time difference in pulse reception at 2 points is measured to obtain angle. Remember that, please. Here is angle taken in calculation. This type of system may operate in ping or passive mode. Passive hydrophones and beacons sending continuously pulses are used, and only signal angles are measured and depth has to be known. Or this type of arrangement may operate in transporter mode. They call it active. Here, reply transporters allow measure the range, depths do not have to be known. Usually more than 3 hydrophones required to have a redundancy, due to the thrust wash, for example. So gents, here we have angle measurement to obtain the idea about relative vessel position. Let's find out what is ultra-short baseline arrangement. In ultra-short baseline, in a single head transducer, we have many small elements, and the distance between elements in the transducer head is about 10 centimeters, which forms a baseline. That's what is important. Usbl is a system where inside of transducer head we have small transmitter and many hydrophone elements inside of the transducer unit. Generally, the distance between elements in the transducer of ultra-short baseline system is, as I said, about less than 10 centimeters. But in modern generation systems, we have extremely small distance between each single element. The system computes the relative position of the transporter from the transducer in terms of a range and a bearing references to the system's heading unit. This usually the ship's or the survey gyro compass or any other heading sensor. But the main advantage of this type of arrangement is that the only one transducer head and only one beacon makes the system fully operational at let's say extremely high depths also. So the main idea of ultra-short baseline system is that the system measures a range and angle from the vessel-mounted single transducer to a transporter on the sea floor. I insist once again, range and angle. The minimum 3 acoustic sensors are located across one transducer head, creating super short baseline, as you know, less than 10 centimeters. The angle of an arrival of acoustic signal is measured by phase comparison of received acoustic pulses, observed simultaneously in 2 sensors. So, the accuracy of the system depended on gyro and MRU module. MRU means motion reference unit, which measures pitch, roll, and sometimes heave, and 1% to 2% of water depth. So this is our operational accuracy. And please look at the sketch provided. Here you see that ultra-short baseline as a minimum must have at least one transporter TX and 3 receivers to be able to recognize the phase difference of the pulses received. Guys, few words about operational frequencies and the range coverage when we use hydroacoustic equipment. So our low frequency body varies from 8 till 16 kHz, and if the system configured to use that amount of frequencies, we have a maximum operational range about 10 kilometers. At medium frequencies, which are varying from 18 till 36 kHz, we have the operational distance from 2 till 3 kilometers, maybe 3.5. High frequency, which bordered from 30 till 64 kHz, gives us the operational distance about 1200 meters. And extra high frequency, which lays between 50 till 110 kilohertz, is normally gives us maximum range about 700 meters. And the availability and selection of frequencies for use in deep water acoustic positioning is generally limited to the lower and medium frequencies, which I said you from 8 till 16 kilohertz. When considering any systems that transmit through the complete water column. For systems operating exclusively at the seabed, the choice of frequencies is wider and varies from 15 till 75 kHz. And for very accurate solutions, still higher frequencies are used, let's say from 40 till 100 kHz. So I cannot give you the answer in one sentence at what frequency HPR system is normally working. It depends what kind of work and type of operations we have, and then what type of frequencies are utilized. So that information is provided to you from Industrial Operational Guidance created by IMCA.